ChaCha is an example of a more modern random number generator that is considered cryptographically secure. The state of ChaCha is 64 bits, so it's considerably more compact than RC4, and yet can give us better results. Those 64 bits are initialized with some constants in the first 32 bytes, a 64-byte key that is provided to initialize the state, plus a counter and a nonce. The counter and the nonce are really extensions of the key, but this random number generator has the property that it's okay for communicating parties, Alice and Bob, to agree on a key and then communicate multiple messages using that same key by using a different nonce for each message, perhaps even just counting up from 0. Counter is very similar, but the intent is that counter is used for different parts of a single message, while nonce is used for different messages. In any case, we take these pieces and we initialize the state like this. The funny word expand to byte k is meant to be just a non-magic number. Something needs to be used to fill out this space, and it's called a nothing up my sleeve number to say we just needed some number to put here. There's nothing special about the numbers we used that doesn't give us a backdoor into this algorithm. Once the state is initialized with the given key, counter, and nonce, then every time we ask for a random number generator from ChaCha, it's going to shift things around in this box. And it's going to do it by using this quarter round function on columns. So A, B, C, and D correspond to different cells in a given column. So we'll do it for each of the 4 columns. And then next time, we will do it on the diagonals here. So the diagonal that goes across, the diagonal that it goes across here and wraps around, and so on. It's called a quarter round because we will do columns once, and then diagonals once, and then columns once, and then diagonals once again. Each of these operations does an XOR on a couple of the cells, and then it also shifts one of the cells to the left by some number of bits with wraparound. So the 3 arrows equal here is meant to say shift to the left. Any bits that would fall off at the high end, you move around and bring them back in on the low end. So we see once again an XOR operator to mix things up, but also going across columns and diagonals to get some diffusion of the state across different parts of the box. So it's a little more arithmetic than RC4, but it's a kind of arithmetic that the processor can do in parallel quite well and much less state to preserve, which makes the random number generator faster in a different way. And there are currently no known attacks of this random number generator. That is, no detected patterns that shouldn't be in the generated pseudo-random numbers, and no way to take the current state of the random number generator and work your way back to see where it came from. So if all you need is a stream cipher, and all you need for your stream cipher is a good random number generator, ChaCha could be a good choice.